So continuing on in this transition to algebra, that's what 1.4 is actually called. We've gone through the properties of real numbers, the associative, the commutative, the associative, and the distributive. We've talked about adding and subtracting real numbers, and we've talked about multiplying and dividing real numbers. And things are getting increasingly complicated. So now is a good time to throw in some letters to all of this. And really, that's what we're doing. We're using symbols and the language of algebra. So we're staying with the addition, subtraction, multiplication, and division, right, in all of its ways of being written. We're going to deal with numbers, and we're going to deal with letters now. So letters in math we call variables. So a variable is a letter used to represent a number. In algebra, oftentimes you're solving for x, right? X might equal 2 or 3 or whatever. So in this transition, we are going to involve a little bit of English. And this is where things get even worse. So now we're talking about English and grammar and math with numbers and letters. So this one can be a little tricky, but I just encourage you to use some patience with this. Okay, so keywords, if we're going to translate words, we're going to translate English into algebra. That's what we're doing here. So the keywords for addition would be plus, sum, more than, increased, total, added to, all that. Subtraction is minus, difference, less than, decreased by, subtracted from. Multiplication would be times, by, these are tricky, like 2 by 4, right? Of, that's a really sneaky one. Half of 10 is 5, right? I said of here. So that's what multiplication is. Product, that's the fancy word I used even back in chapter 0. And then you could go into twice, which is 2 times, doubled, which is 2 times, tripled, which is 3 times, right? Okay, so that's multiplication. And then division. Division is divided by, or quotient. That's kind of the parallel to product, big fancy word. And then you could half things, so divide by 2, split into 2 or 3 or 4 or any of that. So the quotient of x and y is the same as x divided by y, or x divided by y, or just one more time, x divided by y, if you really wanted to do long division with them. Okay, so what we're going to do here is translate the words into math. And I've had students in this course where English was their second language, and they were so well, they were curious about this, but they were also frustrated sometimes because English is notoriously imprecise, where math is more precise. So really what we're trying to do is make some sense of this without that interpretation bit that English sometimes has to have part of it. So this one says the sum of A and 3. So we know sum is addition, and the two things that we're adding together are A and 3. A is representing a number. We don't know what that number is. A is my variable here. 5 more than M would be M with 5 more added on. Now you could write 5 plus M. And the reason you can do that is good old commutative property of addition. That's why we learned that stuff in the first place. Either one of these is correct. Okay, so X increased by 7. Most of us will write X plus 7. You could do it in the other order though. 4 less than A. Less than is subtraction. And even though I was just saying up here, order doesn't matter in these ones, it does matter with subtraction. And so 4 less than A, we have to have A minus 4. If I did 4 less than 5, right? Dealing with letter or with numbers only, we'd have 5 minus 4. 4 less than 5 is 1, and we would know that with numbers. So don't forget, what makes sense in numbers also stands for algebra and when we're dealing with these variables. So the order matters here. It is not 4 minus A. That is the wrong. That's not the same thing. Okay, the difference of A minus 7. So a little redundancy here. It didn't really have to say the difference of. You could just say A minus 7. And this is that imprecise nature of English. The last one, the product of A and 5. So there's a number of ways you could write this down. It could be A times 5. It could be A 5. And typically in algebra, we put the number out front and the variable out back. So 5A is most likely, like in your textbook, the way that answer would be given. You can see here the confusion if it was, the product of x and 5, why you wouldn't use x as multiplication here. Okay, so there's a few more to try here. I would encourage you to check the key, or in class, we'll do these ones together. There are a few that are, well, these ones aren't too bad. Everything on this page are pretty good. Sometimes it's almost a debate of where the bracket or the comma should go, or something like that. So give those ones a go, and we'll move on in the notes a little quick here, but we will take a break in class to do these ones. All right, so we are going to, in all of chapter 1, deal with expressions. Expressions are different than equations. So chapter 1 are going to be expressions. Chapter 2 is all about equations. And this is the first time I'm going to say this, but it will not be the last time. Expressions, all you can do with expressions is simplify. Even if they have letters in them, you can't tell me what x equals. You can't tell me what a equals, right? Unless the question does, but you can't solve them. Equations you can solve. And that's what we're not going to do until chapter 2. We're not going to solve equations. In chapter 1, we're just simplifying expressions. So we should start off with what the heck an expression is. So an expression is a meaningful, I love that, hopefully it's meaningful to you, collection of numbers, variables, which those were letters, and symbols of operation. So those could be grouping signs, they could be addition, subtraction, multiplication, all of that. So which of these are expressions? And we can go through these ones just by giving them a check or an X. Is it an expression or not? So A is 2m plus 3. That is an expression. B, I'm really not sure what's going on with B. This is not meaningful. I'm not sure what those are trying to do. Makes it not an expression. C, an expression. D, it is not an expression. And the problem with it is that it has this equal to sign in it. When it has an equal to sign, this is an equation. And equations are different in math than are expressions. And so that's why it is not an expression. Moving on here, E is an expression and F is an expression. So the next example of expressions here are from geometry. And so you have either on the inside cover of your textbook or on the purple formula pages that I gave you a lot of these expressions. And so I would encourage you to take a look at your formula sheet to just start reacquainting yourself with some of these expressions. So the area of a rectangle is length times width. The area of a triangle is a half of the base times the height. And if you're looking at this would be your base, this would be your height. Area of a circle, this one is pi r squared. And the reason I know it's pi r squared is because it's the area. And just as a reminder, circle, this is radius, right? This is diameter. So all the way across. The radius is half of the diameter. Okay, one more expression. You'll notice there's no equal to signs in these. The volume of a cube is, side times side times side. And this is where we could talk about your exponent notation. That is a side cubed, the length of a side cubed. Sometimes I don't like S's because they start to look like 5s in my handwriting. Volume of a rectangular prism, the volume of a box basically, is length times width times height. Circumference of a circle, so this is the area or the length of it going around, is pi d or 2 pi r, because I talked about how the radius was really half of the diameter, or the diameter is really 2 radius. Perimeter of a triangle is side 1 plus side 2 plus side 3. Now, this is the first time that we haven't used different letters here. So we kept using S, but the S's have this subscript down below. And so that indicates that they could have different lengths, right? They could have all the same lengths, but it's indicating 3 different sides added together. The other one where that gets used is in physics. So if you have acceleration, you have velocities, but you're going to have an initial velocity and you're going to have a secondary velocity. And so these are just examples of subscripts with variables, and sometimes those get used in math. So perimeter of a square, so we'd have side plus side plus side plus side, or really 4 times the length of that side. And so either of those would be acceptable as an expression illustrating the perimeter of a square. Perimeter of a rectangle, if I were to draw this, and if you take a look at your formula sheet, you have your lengths and your widths, right? So you could just literally add all those up together, or you could say 2 times the length plus 2 times the width. And that's what it says on your formula sheet. And hopefully that can help you make some sense of those. So those are always available to you. You don't have to have them memorized, but they are useful. So we do have a few more to do here. And again, maybe I'll put the answers up for what I can. And in class, we can take our time and discuss these ones a little bit more. They are a little bit trickier, and I would say that B is a little bit ambiguous. So you might have a different answer for B. After I put the answers up, then we can talk about those. So in all of those, you can choose to use a different letter. I used X's and A's somewhat randomly. It really doesn't matter what letter you use. And like I said, some of these are different. So come to me and chat, or we can in class discuss the ambiguities or what you might have that maybe looks different, but maybe you're still right.